Hello, welcome viewers. In today's class, we want to consider the topic projectiles. And of course, we know too well that a projectile is any object that is projected into the air. By the definition we have here, a projectile is an object which is projected into the air and it is allowed to move under the influence of gravity alone. So any object projected into the air and is allowed to move under the influence of gravity is referred to as a projectile. The path in which the projectile moves is called the trajectory. So you can see the kind of projectile we are going to consider for this very example is the one that is projected from a height above the ground. We are still going to look at other ones, but for today, we are looking at a projectile where the object is being projected from a high building or a tower. So you can see if you look at the figure here, figure 1, you see the height above the ground and then the horizontal velocity of projection, and then the R here represents the range. So this is the path in which the object being projected moved, the trajectory. Okay, let's go down and look at some expressions which we are going to use in solving most of this problem. A body projected horizontally with a velocity u from a height h, as shown in the figure above. Okay, the horizontal and vertical distance covered is given by equation 1 and 2. So you look at this equation 1 here is for the horizontal displacement of an object being projected from a height above the ground. Let me magnify it so that you can see it. And then this is the vertical distance as well. The horizontal distance is ut, product of the initial velocity and the time of flight, and then y here is 1/2 gt squared. Okay. If we differentiate equation 1 and then equation 2, it will give us the horizontal velocity. So equation 1 here is the distance, and the first derivative of the particle gives us the velocity. So in this case, we'll have ux to be equivalent to u. Let's call this equation 3. And then if we do the same thing to y, finding the first derivative of 1/2 gt squared would give us the vertical velocity, which is gt. You can as well try that. Okay, so equation 5 would help us to calculate the time of flight of a projectile that is projected from a high tower like the one we are considering here. So in this case, t equals to square root of 2h over g, where h is the height above the ground and g is the acceleration due to gravity. The acceleration due to gravity most of the times could be assumed to be 10 meters per second square or 9.8 meters per second square, depending on what the material or the textbook you are using is considering. Okay, so the range is the horizontal distance where the projectile is being projected to where it falls to the ground. Again, look at this figure here, you can see R. This represents the range. So the range is equal to UT. So the U in this case is the component of the horizontal velocity, and then the T here is the time of flight that we've just discussed. Okay, so you see UT, horizontal velocity, and then 2h over g. The magnitude, if we are to find the magnitude of the resultant velocity, then we have the expression v square x plus v square y. If we go back to the equations here, equation 3 and 4, we have vx, the horizontal velocity, and then vy, the vertical velocity. So we are going to find the square of the horizontal velocity and the square of the vertical velocity. That is what will give us the magnitude. So if we don't use vx, we can use u depending on what is given. And if we don't use vy, we can use gt. So let's go back to that expression. That's why we have u square here plus g square t square, or v square x plus v square y. Okay, and then that is for the magnitude. Okay, so the next thing we are going to consider before we solve at least one problem is the angle alpha, the angle which the resultant vector, the angle which the resultant velocity vector makes with the vertical, and that angle is given by tan alpha equals to Vx over Vy, or we can as well write it as U over Gt, still from equation 3 and 4. Okay, so let's quickly look at this problem. Example 1. The example says, let me magnify this so we can see clearly. The example says, a body is projected horizontally with a velocity of 10 meters per second from the top of a building 20 meters high. So, by looking at this, you would have a picture of how the figure would look like. Let me continue first. Find A, the horizontal distance from the foot of the building where the ball hits the ground. B, the magnitude and direction of the velocity of the body 1 second after it is projected. So if we look at the example again, a body is projected horizontally with a velocity of 10 meters per second from the top of a building 20 meters high. We already know how the shape of the projectile would be. So let me quickly come back here and then pick the shape here as the first thing. As the first thing to consider. So this is how the figure would look like. So h here represents the height, and the u given is the initial velocity u in that problem, and r is the range. So v is 10 meters per second. V is 10 meters per second, and then the height is 20 meters. V equals to 10 meters per second, and h equals to 20 meters. We are asked to find a horizontal distance from the foot of the building where the ball hits the ground again. Looking at the figure, the horizontal distance is the range, the distance from the point of projection to where the projectile gets to the ground again. So the range r is equal to u times t. Now, we have the u here, but we don't have the time. So we are going to solve for the time, and then with that we would be able to find the range because we already have u. So let's go to the expression which we are going to use, which is equation 5, the time of light. So the time of light is given by t equals to root 2h all over g. And in the equation we have h. Okay, so let's assume that g, since g was not given, let's just assume that g is 10 meters per second square. 10 meters per second square. And that's what we are going to use to find the t before we come back and then find the range. So without the time t, the time of light, we are not going to be able to get the range. So here, to save time, let me just edit. The height was 20. Two times the height all over 10. So g is 10. I put 10 here. 2 times 20 gives us 40. So we have 40 divided by 10. 40 divided by 10 would give us 4. So we will now have square root of 4 here. And then, what's the square root of 4? Definitely that will give us 2. So 2 seconds for the time. So we now come to the r here. We had u to be 10 meters per second. 10 meters per second times 2, which is the time t. the time of light. So that would give us 10 times 2, 20 meters. Range is measured in meters because it is a horizontal distance. Okay. Let's now move down to the second point. The magnitude and direction of the velocity of the body 1 second after it is projected. The magnitude, okay, G was given here in this. Okay, the magnitude and direction of the velocity of the body. So magnitude and direction, what was the expression? It's always good to memorize it. You're going to use equation 7. Equation 7. Let me call this B. All right. And then we have to solve for v square x and v square y so that we can be able to get the magnitude. So the v square x or the vx per se, the vx according to our formula is the horizontal velocity. Vx is u. So from the equation, let me just pick this down. Okay, Vx equals to u. Our u in the equation was 10. Our u in the equation was 10. So here I am going to put u is equals to 10 meters per second. And then Vy would be g times t. And the g is given to be 10 times the t. According to B, t is 1. Let's go back so you see it very well. So find the magnitude and direction of the velocity of the body 1 second after it was projected. So we are going to put 1 second in place of t here. So when we do that, 10 times 1 is 10 meters per second. Now, we are going to apply the expression for the magnitude. So in place of Vx, we are going to substitute 10 square. And in place of Vy, we are going to substitute 10 square as well. So let me just edit what we have here. Let me edit this and put 10. And then I edit this and put 10. 10 square is 100. And 10 square is 100. So this one reduces to 100. And this other one too reduces to 100. 100 plus 100 would give us 200. So the magnitude in this case is the square root of 200. From such, we can simply write this as let me simplify this. This will be 10 root 2. 10 root 2. So we will now have the velocity to be 10 root 2. You can as well use your calculator to simplify it, and whatever it gives you becomes the velocity. But I intend to use this. I intend to use the short form. Alright. Then let's still go back because we have not finished. We were asked to find magnitude and direction. So for us to get the direction, we are going to use the formula for the angle. The formula for the angle, which is equation 8. So let me take this down. Already we were able to solve for Vx, which was 10. Vx, which was u, which is the same thing as 10. And then our gt was 10 times 1, which was still 10. Or we can say that vy is 10. So here I put 10. 10 divided by 10 will give us 1. So we have that tan alpha is equals to 1. Tan alpha is equal to 1. So if we are to solve for alpha, then we have to make alpha the subject of the expression. And when we make alpha the subject of the expression, we will have alpha equals to inverse tan, then we put the value of 1. Alpha equals to inverse tan, and then we put the value of 1. Okay, so tan inverse of 1, that's how to represent it, would give us 45 degrees. Okay, that will give us 45 degrees. So I think that's how far we can go for today. And I would like you to encourage us by clicking on the subscribe button, like, and also make comments and share to your friends. Thank you very much and have a wonderful day. Bye.